Okay, I'm going to make a circuit likely more complicated than the Regents would ever give you, but just in case. I'm going to put a mixed circuit. It's going to be super mixed. It's going to be the most mixed of all circuits. It's going to include a series resistor. Series meaning everything has to go through it. It's going to include a parallel resistor. Parallel meaning it has a choice which one it wants to go through. It's going to include two series resistors that are in parallel with this resistor. That's it. Here's my super complicated circuit. It doesn't matter what all these numbers are, but just for fun, let's make them different things. Let's make this one 15. Let's make this one 10. Let's make this one 20. And we'll let this one be 10 also. Okay. So many questions I could ask. What's the total current? What's the total equivalent resistance? What's the current just through this? What's the current just through this? What's the power on just this resistor? What's the power on just this resistor? Let's just solve this entire thing. Let's solve everything. The first place I'm going to start is I'm going to find the equivalent resistance. And so here's what I'm going to do. It's probably best if you guys grab a pen and paper and you copy down what's happening. All right. So let's draw the circuit out. And I'm going to be erasing stuff because I don't have that much space. But what I want you to do is I want you to constantly draw new circuits every time we do something. All right. I need to go back and look at what I made them because I don't remember what I made them. So let's see. I've got a 10 ohm. So R1 is 10 ohms. Let's call this R2. I made R2 20 ohms. I made R3 15 ohms. And I made R4 10 ohms. Okay. There's my resistor. You should draw that. You should draw that whole circuit. That should be connected. But you should draw that whole circuit. And what I'm going to do is I'm going to find equivalent resistances, and we're going to draw a new circuit every time we find equivalent resistances. So the first thing I'm going to do is I'm going to start the smallest pieces I can. The smallest piece I can where I need to do something is up here. This 15 ohm plus this 10 ohm are in series. We know that when we add in series, it's simply R1 plus R2. So what happens is after you draw this circuit, we have an equivalent circuit that would be the same thing. And I want you to draw this as a brand new circuit. I don't want you to erase. I want you to draw this as a brand new circuit. Your brand new circuit looks like this, where this is a 25 ohm resistor. This circuit is equivalent to the other one. Okay. Next, I'm going to take care of these parallel ones. All right, so I have got these two parallel ones. I've got 1 over Req will be 1 over R1. Sorry, yeah, we'll call this R3 now for our new circuit. 1 over R2 plus 1 over R3 because I called that R1. I just don't want to mix things up. So 1 over 25 ohms plus 1 over 20 ohms. Oh man, I got to find a common denominator. What do you want to use? Let's just use 100, huh? So I got 4 over 100 ohms plus 5 over 100 ohms. 9 over 100 ohms equals 1 over Req. And so Req equals 100 ohms over 9, which is what? 11-ish? So Req is 11.1 ohms. Okay, so now we draw a brand new circuit. And your brand new circuit, I'm just going to erase, looks like this. This is the equivalent circuit. So instead of having these parallel circuits that I had before, or these parallel resistors in addition to this resistor. Now, this circuit is essentially the same thing. That resistance is the same, so I'll get the same information from this circuit as I would from the other one. Then these are in series. I'm not going to bother writing it out right now. If this were a test, if this were the Regents, if this were homework, you have to show the work, right? But I'm assuming everybody understands. Our EQ for a series is R1 plus R2. I guess I ended up writing it down anyway. It's 10 ohms plus 11.1 ohms is 21.1 ohms. And now finally, our very last picture looks like this. This is the equivalent circuit. So all the way from the beginning, we have what, 4 pictures. This is the equivalent circuit to that crazy circuit from the beginning. So this circuit is equivalent to this circuit. And now that I have this circuit, I can find some information. So let's start here. Let's see, my voltage was 20 volts. So let's do the current total through this circuit is the voltage total divided by the resistance total, which is 20 volts divided by 21.1 ohms, and that is 0.95 amps. So this circuit gets 0.95 amps. Cool. Now that I did this and I found out the current that it gets, I'm going to go back to my crazy complicated circuit. I total is 0.95 amps. By the way, if I know I total and V total, I can find the power total, right? Okay, resistor 1, 2, 3, 4. Our resistors had values of, because I didn't write this down, 10 ohms, 20 ohms, 15 ohms, and 10 ohms. So now we go back and we start answering some questions. How much current flows through here? Well, I know how much current flows through here. I know that's 0.95 amps. I know how much current flows through here. I know that's 0.95 amps. What I don't know is how that current's going to split up. I don't know yet. Couldn't tell you. I know it's going to recombine over here to be 0.95 amps. So in order to go through this complicated circuit, I have to start with this. I have to find the voltage drop. If I attached a voltmeter, what would be the voltage drop on that 10 ohm resistor? And that voltage drop on that 10 ohm resistor, we'll call this resistor 1, equals I1R1, which will be 0.95 amps times 10 ohms. So it is 9.5 volts. I now know that voltage on resistor 1 is 9.5 volts. Cool. This lost 9.5 volts from that 20 volts. That means there are 11.5 volts, there are 10.5 volts left over. So there are 10.5 volts left over. So a coulomb of charge hits this resistor. It had 20 joules of energy. It gave up 9.5 joules of energy to get through this resistor. And now it has 9.5 joules of energy. And it gets to choose which way it wants to go with that 9.5 joules of energy. So if it chooses to go this way with 9.5 joules, or if it chooses to go this way with 9.5 joules, either way, both of these parallel things get all 9.5 joules. How is that going to get split up here? I'm not sure yet, but let's continue. I know if there are, 10.5 joules, 10.5 joules, or 10.5 joules that go each way because this lost 9.5 joules. So I know that if I put a voltmeter here, that voltmeter would read 10.5 joules. That means I can find the current here. Cool. The current through 2 is V2 over R2, which is 10.5 volts over 20 ohms. The current through that, I2 is 0.5, we'll call it 0.53 amps. So I2 equals 0.53 amps. Well, if 0.53 amps went this way, how many amps went that way? Easy. 0.95 amps minus 0.53 amps. What's left over? 0.42 amps. So 0.42 amps go this way, 0.53 amps go this way. So 0.53 amps go this way, 0.42 amps go that way. Our numbers, depending upon the way we do this, might be slightly different, right? I could have calculated this resistance and found this current instead. So in fact, let's do that. And based on rounding, the numbers might be a tiny bit different, but it's not a big deal. Let's pretend the current went this way, let's take this voltage, which I know is 10.5 volts, and I know the total resistance here is 25 ohms. And let's find what the current is that way using a different method. So I take my 10.5 volts and I divide by 25, and I get, 0.42 amps. So no matter what method we use, we found 0.42 amps goes that way. Now that I know the current, I could find the individual voltages. For instance, let's find the voltage on this 10 ohm resistor. The voltage on the 10 ohm resistor would be I through it times its R. The I through it is 0.42 amps. Its resistance is 10 ohms, so this would get 4.2 volts. If this gets 4.2 volts, and remember, this whole thing right here should be getting 10.5 volts. So 10.5 minus 4.2 volts, 3, 6. So this should get 6.3 volts. Can we check that? Sure. Let's check it. 0.42 amps, so V equals IR, times 15 ohms. 6.3 volts. I just showed you a bunch of different ways to do stuff. That's all this was, okay? There's more than one way to do this. What if I wanted to find the power here? I just plug in the power equation for this resistor or the total circuit. What if I wanted to find the energy after 3 seconds? I just take the power and multiply by the time of 3 seconds, all right? So I'll answer questions about this on Monday as you guys go through and do it.